Assalamualaikum and a very good evening. We are from group We Electrify Your Life. We would like to present about our assignment, which is Cockroft, Walton, Doubler. Before we proceed our assignment, actually we are on our holiday mood, but we still would like to proceed with our assignment because of Isham. Okay. Okay, so what if Cockroft, Walton, Doubler circuit? Okay, before I go on any further, this is the process of changing AC current to DC current. Before exist this Walton Doubler circuit, actually there's a two method. First one by using by converting the AC to DC using just LED and capacitor. And then there's an invention of using two LED and two capacitor and one capacitor, but because of that method, the loss is a lot and we cannot set the loss because this is high voltage. We want to maximize the input and the output based on the input. Okay, without any hesitation, we would like to go to the next part. So this is the objective of our project, is to be able to do the simulation and to do the hardware for the Cockroft Walton Doubler circuit.
Okay, so for the introductions, Cockroft Walton Doubler circuit will produce a DC voltage first, almost double 2 Vmax. The peak AC voltage is the underload condition. So the next point is the circuit name is named before the creator. Name is Green Nature, or also known as Cockroft Walton. After the two men who used this circuit design to be the first to succeed in 1932. So by using only capacitors and diodes, this voltage multipliers can step up low voltage to extremely high values. Okay, that's how Cockroft Walton go.
That is a useful information, Isham.
Yeah.
Good one.
Okay.
Okay, this circuit, can you zoom?
Can you go to the circuit? Do you see the circuit inside the camera?
This circuit that has been told by our lecturer, Dr. Hafiz. My name also Hafiz. I want to be a lecturer. Okay, this circuit actually, for this like a full wave rectifier, they have negative cycle and positive cycle. For the positive cycle, they can see that from 0 and go to diode D1 and go to A and go to the capacitor. The capacitor will charge. When the capacitor is charged, it called to Vmax. And then for the negative cycle, from from A to diode and go to C. After the C1 is charged, it will transfer to another capacitor. So it will produce 2 Vmax because of capacitor. This is Vmax and this is Vmax, and we call 2 Vmax. That is why the output is bigger at the output. Okay. Okay, next.
So for the simulation, so this is how we simulate in the application that's called
P-Spice.
LT-Spice. So this is the circuit that we implement in the simulation. This is 2 capacitor here, like Hafiz said, and 2 diode here. So the output that have multiplied that we have been simulate is here, the green one.
The green is our input. For
So
the blue one
one
is our output. You can see that this green is sine wave. So sine wave is AC, and at the output you can see that the blue one is a DC.
Yeah, it's stepping up.
You can see we use 5.303 input, and we can see our multiple.
Our output is multiplied by the input.
Yes.
Yeah, that's how. So
Right.
for the next slide is the hardware.
Next is on the hardware. the hardware is just the implementation of the simulation circuit. As we can see here again, we are using 2 diode over here and 2 capacitor over here. The diode we use name IN4148. But actually the diode we can use any kind of diode except for special diode like Zener diode and so on. This is just a normal diode. You can even use an LED, right, gang?
Yes, but it has power loss, right?
No. It doesn't have any power loss.
Yeah, okay.
And then as we can see here, this is the input of the AC voltage, 15 volt. And then we are using multimeter to see the value of input and output. As we can see here, the value of AC input, by using some formula, we could get the value of peak, which is 5.34. And then we can see the output value over here, it turned to
DC.
10.6. It means that it is 2 times, right? You can see the value is 2 times. 5.3 times by 2, we get 10.6. No loss, no worry.
Question.
Okay, so this is the. So I will discuss about the assignment that we have been done. So the purpose of the assignment actually to implement the theory of the Cockroft Walton doubler into the simulation and hardware. We know that by just doing the simulation, and if we do not do the hardware, so we don't know actually what we learn in the class. Okay, so just for this simulation and hardware, we are using 2 kind of electronic equipment, which is diode and capacitor. We are using IN4148 diode, and also the capacitor is 2.2 microfarad. Why we are using 2.2 micro? Because this capacitor we can get in the lab. Okay, so there is calculation below here. Okay, the calculation below here is to justify the result that we get by using the multimeter. Okay, we know that when we set at the voltage generator, we set with 15 VPP, which means 15 voltage peak to peak, which means the scale is from the Vmax until the V minimum. Okay, the Vmax until the V minimum. So we need, if we want to know the maximum amplitude for the input, we need to divide the VPP by 2. So we get that 7.5 VP, which means
Cert 2.
no, wait. We get 7.5 VP, which means that that's from 0 until 7.5 is the V peak of the graph input. Okay, so how do we know that the voltage is double? Okay, this is how the calculation. Okay, the voltage actually has been set to 7.5 VP for the input. So as we measure in the multimeter, so we get that the value is 5.3417. The value 5.3417 we get by using the formula of VRMS change to VDC, right? So VRMS we divide by square root of 2, so we get 5.3417. So we measure the output and we get that around 10.6320 volt. So when we multiply by square root of 2, we get that 15 VP, which means that the voltage actually is double.
It's proof, right?
It's
So
proof.
you can see this our hardware. This is 5.3410 is this, and this 10 is we get from output, and this is for 0.5 and 15 we can see from our simulation. This 5
volt, and then this is 10 volt. It actually will increase until it stop.
Yes.
The store, what we call that? Store.
Pick 2V+.
Stop lah. Okay, conclusion. Go. Conclusion.
Apa baru?
Okay.
Conclusion. So, we know that the experiment is actually proof. Which mean that we get the result.
Yeah.
But unfortunately, we have some problem in getting the result by using the oscilloscope, right?
Yeah,
Yeah.
graph.
The graph is actually not
Not correct.
not correct.
Yeah.
Because
But when we measure it by using the multimeter, the result show is double. But by using the oscilloscope, the result shows the opposite result.
I think why we don't get the result based on the oscilloscope because of the shifting of the
Time.
No, it's not the time shifting. It's the graph shifting. It shift to up 2 times. So then the oscilloscope cannot read the shifting, and then it cut a bit of the graph, and then the graph it produces half of the wave.
And maybe some oscilloscope have broken, right?
Yeah.
Many of
We all know that the
So
oscilloscope.
conclusion is this Cockroft is very cheap. You can implement that from buying a new transformer. Can step up 1 volt to 2 volt, maybe about 100. But this method you can get maybe 50 ringgit, I think. Yeah, it's very cheap.
But actually it depends because on the higher rating you need the even higher rating of capacitor too. So then it's going to be a bit more expensive rather than what we are saying. 50 ringgit is so cheap.
Yeah, we can implement this circuit by using a multiplier. It's set 5 stage, right?
The maximum that it can support only 5 stage.
So we just show one step. Maybe you can do it at home.
So we are going to conclude our presentation here. That this Cockroft Walton is a really useful things that we have learned. We would like to thank you as our lecturer that give us this opportunity to learn about this. So anyone to add?
I guess that's all from us. Thank you.
Thank you.